back, and we are doing my favorite demo of the year, and you'll see why. It's awesome, it's exciting, and I'm not just saying that because, well, I would be the type of person who'd say that and not mean it, but I do mean it this time. So what we've got going on here, let's give you an idea of the stuff that we're working with. It is in a bottle. That bottle is in a bag. That bag is in a hydrophilic sand that absorbs any moisture that gets to it. And that sand is in another container. Oh, and the stuff that we're going to be using is suspended in oil to keep water and air away from it too. So that's a lot of layers of protection. That's how it's stored. That'll give you an idea of what all is going on in here. It's pretty involved. Now, we have the largest beaker that I could find in our building. It's 3,500 milliliters filled up, 3,500 milliliters full of water. We also have, as you can see, if I back up here far enough, I've got the blast shield up. And we're gonna need the blast shield today. Blast shield's there. It's not the cleanest thing, but it works. It does its job. It keeps everybody safe, including me. And hopefully it will keep my computer safe because I've got it set up to do close-up of the different reactions that happen. So I'm going to turn this off for a second, put it on the tripod, get ready to go. All right, so I'm all set up and ready. I'm ready to do this. So of everything that we do all year, this is the most don't try this at home that you're going to get to. Blast shield, right? Also, you can't see it, but if you're in my classroom, you know this story by now. There's burn marks on the ceiling from when I did this last year, so keep that in mind. So we've been working with the periodic table, and I wanted to show you a little bit about some of the craziness that happens, right? So if you think that very first column in the periodic table, right, hydrogen is there. Right underneath hydrogen, number 3 is lithium. And I've got a little piece of lithium here that I'm going to take it out of the oil, and I'm going to take this little tiny piece of lithium and I'm going to drop it into my giant thing of water. And I don't know if you can hear it, but you should be able to see it. It is bubbling. It is letting off some gas. It is making all sorts of noise. It is reacting to the water like crazy. It's also getting smaller as it reacts. But that's a pretty impressive result. Now, next to lithium in the periodic table is beryllium, and I don't have any of that. But what I do have is below that, and that would be magnesium. And the magnesium here, actually, I can guarantee you I don't need the forceps for this one. Because the magnesium, when I put this in the water, you know what happens? Nothing. So just by, we moved from one column to the next, we get a much different result. The magnesium just sinks to the bottom. It doesn't do anything. Right below magnesium, though, is calcium. If I pull out my jar of calcium. Now, for this, if you think about it, we are over 1, but we're 2 rows in the periodic table below lithium. And when it gets going, it sinks because it's heavier, but it will do a very similar reaction to the lithium did. It is bubbling like crazy. It's creating all these bubbles. It's a pretty big, pretty strong reaction. But to get that same reaction as lithium, we had to move down 2 rows. So if the first column is the most reactive column, and the second one is much less, right? Because you saw what magnesium didn't do. That would be anything, right? As you get lower, it gets more reactive. Hence, magnesium doing nothing and calcium doing something. So that leads us to the next one, which will be the last one. And what we've got here is sodium. Now, this is the same sodium that is in things like table salt and whatnot, but this is pure metallic sodium. I'm going to pull out a chunk out of this, and I'll show it to you. So that is a chunk of sodium. It's kind of white in color. It's metallic. It's kind of soft. It's metal. It's stored in the oil, in the bag, or in the container, in the bag, in the sand, in the container. And even then we keep it away from stuff. So, my calcium's over here still bubbling a little bit. I want to wait for it to finish. But, what do you think is going to happen? Because if moving down makes, on the periodic table, makes something less stable, more reactive. And we already saw what moving down from magnesium to calcium did, and we saw what lithium did in its, well, when it got put in there. So this is below lithium. So we had something that was really reactive before, and now we get to this, and there's a reason there's a blast shield. So I'm going to drop this in, and then you won't see me on camera because I am going to not be behind the shield. So, ready? Keep an eye on what goes down here. Come on, do it. Do it. This is disappointing. This has never happened to me before. I mean, we dropped metal into water and it's just burning, but it's not doing what I want it to do.
It's not exploding.
And I can't go over there to do anything about it. So we're just going to have to sit here and watch it burn. That is the least interesting version of this reaction that I have ever had. So we're going to try again. What do you say about that? So I got another piece of sodium here. See, more sodium. And this time, I'm going to dunk it a little bit to wash the oil off so that we get the reaction to happen faster. And then I'm going to run. I've got a mess to clean up. I hope you enjoyed the video. The power of science.